Welcome back. Having discussed the issues related to construction errors with concrete in our previous episodes, let's explore the design mix approval process in this video. A design mix is a specific formulation of concrete that meets predetermined requirements for strength, durability, and workability for a particular application. It involves selecting precise proportions of cement, aggregates, of course, both fine and coarse aggregates, water, and any admixtures as required. To clarify, we can outline the process with the steps like initial mix to sampling, then compacting, then curing, testing, that includes slump test, adjustment as required, then slump test, then final mix design. Let's understand now about the design mix considerations as per IS 10262. Selection of grade. The approval of the design mix is based on the concrete grade. Grade differs for each material. For example, grade of steel that indicates the specific properties and composition of a steel alloy. Similarly, cement grade. For instance, 33 grade cement achieves a compressive strength of 33 newtons per mm square, which is inadequate for higher structures. You can refer to ASTM C109, compressive strength of hydraulic cement mortars, for more information. It is important to note that we provided several standard references, but they are not exhaustive. We need to clarify the specific requirements, such as whether they pertain to concrete, blast, or mortar, as well as the intended location of use like foundation, walls, or ceilings, since the requirements and relevant standards differ for each. For example, while IS 2386 is the standard for testing coarse and fine aggregates, IS 1542 should also be referenced for the grading of sand used in mortar to meet minimum standard requirements alongside IS 2386. Any sieve analysis conducted according to IS 2386 must be checked against the deviation requirements specified for external walls and ceilings. Standards should align with the purpose of the work and the types of materials involved. Additionally, as we mentioned in our previous episode, relevant standards are usually detailed in the documents, but it's important to refer to the latest revisions. For example, IS 1542 cites IS 383 1970, which was reaffirmed in 2002. However, the most current standard is IS 383 2016. This updated standard includes a wider variety of fine and slag aggregates from different sources, such as crushed rocks and steel production. It also addresses the use of mixed sand and crushed sand, provisions for alkali silica reactivity, and the combined index determination of flakiness and elongation, along with their specifications. Concrete grade is nothing but the characteristic compressive strength of concrete at 28 days after curing. Or in simple terms, strength and composition of concrete and the minimum strength the concrete should have following 28 days of construction. Let's say if M25 grade, then it can be literally considered as the ratio of cement, sand, and aggregates as 1:1:2. That is 2 parts of coarse aggregates with 1 parts of cement and sand. But for complex structures, generally above M25 will be used, such as M30, M35, M40, M45, and M60, etc. M denotes concrete grade expressed in megapascals. The next consideration is on selection of raw materials. Cement. Type of cement like ordinary Portland cement or self-compacting cement SCC, grade of the cement, and minimum cement requirement and maximum cement requirement that is required for the mix. Then aggregates. What are the key factors of aggregates? Of course, grade of the aggregates, then size of the aggregate, minimum nominal size of the aggregate. Water. Clean, potable water is essential. Impurity can adversely affect the concrete properties. We have already seen the huge negative impact on high-rise building that used untested water in the concrete mix. Okay, the recent development of this case, the court has ordered to demolish the entire structure, including of all the blocks. The residents are already relocated with the monthly compensation of 30,000 rupees till the new structure is built and the flats are handed over to them. Irreparable, huge bad quality cost borne by the builder that is due to bypassing the critical procedure. This is the reason we are trying to create awareness on right quality procedures using such videos that could help non-technical people as well, so that to cross check on their footprint and question the builder if something found not in order. Okay, let's continue here. The next consideration as per the standard is on admixture. Two factors are to be considered here are purpose of admixture like plasticizer, air entrainer, etc., and the type of admixture along with their conditions. The third one is maximum water cement ratio. Cement consistency test, which determines how much water is needed to create a consistent cement paste based on the weight of the cement, water quantity, and the penetration index. Setting time of cement, average residue percentage for fineness, soundness of cement measured after boiling for a specific duration with the along with the mold, and importantly, the compressive strength of the cement mortar cubes. All these materials undergo various tests to provide the input necessary to finalize the design mix. Then, workability. Each batch of concrete shall be tested for consistency immediately after mixing by one of the methods described in IS 1199-1959, provided that care is taken to ensure that no water or other material is lost. The concrete used for the consistency test may be remixed with the remainder of batch before making the test specimens. The other characteristics are to be considered as per the standards or exposure conditions that are given in the tables 4, 5 in the IS 456. Maximum temperature of concrete during placement, methods for transporting and placing concrete, early age strength requirements if applicable, testing equipment requirements like compressive testing machines, thermometer, slam cone, etc. Okay, is there any defined methods to do this? Yes, definitely. Decision on method of mixed design. Commonly, mixed design procedures are derived from IS 10262-2009 Indian Standard for Concrete Mixed Design, which outlines steps for selecting materials and proportions, RACI 211. American Concrete Institute's guidelines for proportioning concrete mixes. There are several established methods for designing concrete mixes that includes absolute volume method, a detailed calculation that determines the volume of each ingredient required to achieve the desired properties. Weight method. This method involves calculating the weight proportions of each component based on the desired concrete volume. Empirical methods. These methods use established guidelines and past experience to estimate mixed proportions. Mixed proportion calculation. What are the parameters?